Oh, hello there. Yeah, you. We're looking on a video on how to use a double pipe heat exchanger. Well, congratulations, you got the right one. In just a few minutes, you'll be going from amateurs to professionals on operating a heat exchanger. But before we get started, let's go over some basics.
What's the purpose of a heat exchanger?
Heat exchangers are used to regulate the heat in a product stream by transferring energy to a neighboring contact stream.
Let's understand some of the scientific concepts. Heat transfer between two streams in a double pipe heat exchanger can be described by doing a simple energy balance on the two streams using the first equation. More importantly, the overall heat transfer of an exchanger can be better understood and modeled using an overall heat transfer coefficient, which refers to how well heat is conducted through a resistant medium. This is expressed in the second equation.
There are several different designs of heat exchangers. The best design is dependent on the objective of the exchanger itself. An important design variable is the flows of the liquids, whether they are in countercurrent flow or co-current flow. Countercurrent flow typically provides a better transfer of energy by maintaining a temperature gradient throughout the exchanger. Double pipe heat exchangers are often used in industry due to their low cost of design and maintenance. They are typically used in the food and beverage industry to cool products such as carbonated beverages using an ammonia-based coolant. However, water is the most common and readily available coolant as is used in this experiment.
Now that we covered the basic information, let's get started on the training. This video will provide you an in-depth training on setting up and analyzing the operation of a double pipe heat exchanger. In addition, we'll be identifying any active and potential safety hazards associated with operating the exchanger.
In the experiment, we used a double pipe heat exchanger and thermocouples to help read the temperature at different points. There are 6 in total. Each have the following locations. Valves are also used to regulate the flow of both the hot and cold water, located here. You'll also see the inlet of the cold water and hot water stream.
Now for the procedure. Step 1. Turn on main power switch. Step 2. Set the temperature controller to 70 degrees Celsius by pressing the set point key and adjusting the increase and decrease keys. Set the flow indicator switch to F cold, then adjust the cold water control valve V cold to reach a flow rate of approximately 1 liter per minute. Step 4. Allow the heat exchanger to stabilize. Keep a record of the cold water exit temperature versus time in your lab notebook so that you can verify the steady state conditions has been reached. After steady state has been reached, record the following: T1, T2, T3, T4, T5, T6, F cold, and F hot. Step 5. Repeat the experiment by adjusting the cold water control valve, V cold, to reach 2 liters per minute. Allow the heat exchanger to reach another steady state and record T1, T2, T3, T4, T5, T6, F cold, and F hot.
Because safety is always number one priority, here are a list of the hazards. The hazards you encounter in the experiment are electrical and heat related. A fire could occur if the reservoir does not have water. Therefore, prior to running the experiment, make sure the reservoir has enough water. To be safe, avoid touching any wet cables throughout the experiment. Also, place a chair above the cold water outlet tube to mitigate the tripping hazard.
For PPE, wear long pants and closed-toed shoes. Because your peers are doing wet chemistry, goggles are required. That is all for today's lesson. I hope you had a good time with us and got to learn something new about heat exchangers. Go Bulls!